All right, tonight you're going to do Lab 1.3. You're going to do the percent error based on the actual results. So follow along as we go here. The first item you measured, or the first on your list, may not be the first you measured, was the height of the classroom. The accepted height is 2.88 meters plus or minus 0.04 meters, which is equivalent to 288 centimeters plus or minus 4 centimeters. So whichever unit you expressed your answer in, that's the one you can do this in. Meters, centimeters was fine, doesn't really matter. Okay, so what do these mean here? There's an accepted range. The range is based on the fact that there's either inconsistencies in the measurement process or in the object being measured itself. Depending on where you were in the classroom, the height of the room varies. So the average seems to be, based on a few measurements, about 2.88 meters, and you can get a variance above and below that of about 4 centimeters. So what this means is that the accepted range is from 2.88 minus, that's the minus right here, 0.04. So from 2.84 meters through 2.88 plus, it's a plus right here, 0.04, which is 2.92 meters. So this is that bracket notation you learned in math. Anything within 2.84 to 2.92 meters, endpoints included, gets a 0% error. A 0% error. Isn't that nice? Yeah. Okay. It's a 0% error. And the way you can write that out on your lab document, I'll do it over here on the left. In your lab document, you have an estimated column. Whatever your estimation is, let's go over a couple examples. Maybe your estimated height was 2.80 meters. Well, if that's the case, the actual height, I would like you to choose the number from this range that is closest to your estimate. Obviously, 2.84 from that range is the closest to your 2.80. So you put 2.84 meters as your actual, and then you do the percent error. And the percent error, make sure you do the measured minus the actual over the actual times 100. So you can get a negative percent error. Okay, anyway, in this case, you would get negative because your estimate was below the actual. What if you got above the range? Well, maybe you got 3.11 meters. Well, pick the number from the range, the magnitude from the range that is closest to your estimate. In this case, you're going to pick the high end of the range of 2.92 meters. That would be your actual. And again, you do your percent error calculation. What if you got within the range? Porridge is not too hot or too cold, it's just right. If you got within the range, maybe you got 2.86 meters. That is within this range of 2.84 to 2.92. So your actual will be 2.86 meters, and your percent error, you don't need to calculate anything, 0%. Okay? So you were doing 1% error calculation, unless you're within the range, and you can just write 0% for each different object you measure. So the classroom, there was the range. The pieces of tape, 1.71 meters plus or minus 2 centimeters. So the accepted range here is from 1.69 meters to 1.73 meters. Again, if you did this in centimeters, that's fine. 169 to 173. The width of the dollar bill in meters, 0.155, which is 15.5 centimeters. The range, you only get 1 millimeter here. So you would go from 0.154 meters to 0.156 meters. There's your range. 15.4 to 15.6 centimeters. Hope you're doing well so far. Diameter of a quarter. There it is. The range, so this is 2.4 centimeters. So 0.023 meters to 0.025 meters. There's the range you get. So from 2.4 to 2.5 centimeters, 2.3 rather, to 2.5 centimeters. By the way, that is almost exactly 1 inch. Very convenient. Okay. The mass of an empty soda can, probably the most difficult one to estimate in the entire lab. The mass of an empty soda can, here it is. It is 12.7 grams, plus or minus a tenth of a gram. If you did it in kilograms, then that range is from 0.0126 kilograms to 0.0128 kilograms. You could have done this in grams, which would have been easier to think about. 12.6 to 12.8 grams, there's your range. The bag of nickels, 1 kilogram, plus or minus 5 grams. So that is from 0.995 kilograms to 1.005 kilograms. So basically 995 grams to 1,005 grams. 1 kilogram bag of nickels. Okay? The mass of Mr. Gruber, 100 kilograms plus or minus 2 kilograms. So the range you get there is from 98 kilograms to 102 kilograms. Anything within that gets 0% error. Anything outside of that, figure it out. Finally, the time we did at the end of class was 23 seconds plus or minus 1. So that's from anything from 22 to 24 seconds will get you full credit. I saw some of you peeking at that clock. Cut it out. All right. On the lab paper, let me go down here. Don't have a copy of the paper in front of me, but that's okay. On the lab paper, there are rather 2 other questions. So those 2 other questions, let me extend down here. You have that big table. At the very bottom of the table, here's the table. Did all your entries. There's 2 things to fill in. Down here is your average percent error. And up here is the bonus question. Let me tell you about each of those. The average percent error. You will have 8% errors over here. You might have negative 3%, positive 5%, maybe at a 0%, negative 17.5%, positive 21%, and so on. So the instruction for the average percent error is as follows. We're going to absolute value all of these. Leave them as they are, just go into the margin and make them all positive. 3, 5, 0, 17.5, 21. Then add them up and divide by 8. That's what I want down here in your average percent error. You're going to pretend they're all positive for the average. Leave them negative inside the table, but pretend they're all positive when you calculate the average. Finally, the bonus question is, how much money was the nickel bag worth? Knowing that it's a 1 kilogram bag of nickels, yes, you can go look something up online if you need to about nickels, figure out and show your work, show your dimensional analysis, which is really this right here, show your ba 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 ba. You start now with 1 kilogram of nickels. Then put the value in dollars of that bag of nickels. All right, cool. This is due in the morning, so do it tonight.